Hi students, welcome to GK Pillai's math classes. This is my first video on the chapter coordinate geometry. Just like arithmetic progressions, this chapter also has many questions in the textbook itself. I will be discussing in this video the fundamentals of the chapter, that is regarding the two important formulae and some important and relatively difficult questions from the textbook. Watch the video till the end and don't forget to subscribe to my channel and share the videos to your friends of 10th standard. I believe you will definitely like my video. Regarding coordinate geometry, let me tell you about the definition. It is just like a definition only. Coordinate geometry has been developed as an algebraic tool for studying geometry of figures. It helps us to study geometry using algebra and understand algebra with the help of geometry. Whatever I have given here are not at all relevant to the questions you are going to do. That is why I am not discussing it further. Let me recall the basics of the chapter coordinate geometry, which you have learned in your earlier classes in 8th and 9th standard. Here there is a point P3, 2 in the coordinate plane. P represents the distance from the y-axis and 2 represents the distance from the x-axis. So the distance of the point from y-axis is called the abscissa. 3 is the abscissa, and the distance of the point from x-axis is called ordinate. 2 is the ordinate. Now another thing, any point on x-axis is of the form x, 0, and any point on y-axis is of the form 0, y. This once again I discussed in the chapter linear equations in two variables also. In this chapter we will be doing sums based on two formulae, the distance formula and the section formula. The first one is for finding the distance between 2 points in a coordinate plane. For example, if you are given a straight line like this and there are 2 points here, P x1 y1 and x2 y2. Now the distance between these 2 points can be found using this formula, under root x2 minus x1 whole squared plus y2 minus y1 whole squared. x2 minus x1 whole squared plus y2 minus y1 whole squared. Since there is a square here, even if you write x1 minus x2 whole squared plus y1 minus y2 whole squared, doesn't matter, you will get the proper answer only. The answer will not be wrong, but it will be always advisable to go according to the given formula only. The next one is section formula. With the help of section formula, we will find the coordinates of a point which divide a particular line or line segment in a particular ratio. Here I have taken the 2 points P x1 y1 and the other point Q x2 y2, and the ratio is m1 is to m2. So using this formula, we will find the two coordinates of this particular point here. m1 x2 plus m2 x1 upon m1 plus m2, comma m1 y2 plus m2 y1 upon m1 plus m2. Here you can see one thing, m1 into x2 plus m2 into x1 upon m1 plus m2, that's the first one. m1 y2 plus m2 y1 upon m1 plus m2 will be the next coordinate. So you can remember that way. This is definitely an important formula for the chapter. The midpoint formula is related to the section formula. With the help of this formula, if there are 2 points x1, y1 and x2, y2 and there is a line segment joining the two, you can find the midpoint of this line segment using this formula. This is of much use in many sums. Many sums you will see this formula being used. x1 plus x2 upon 2, y1 plus y2 upon 2. This is a very easy formula and it is to be used at many places. Let us discuss the first one. The first question. Determine if the points this and this are collinear. Collinear means all the 3 points lie in a straight line. Here what we will be doing, using distance formula, we will find PQ, we will find QR and also PR. PQ plus QR should be equal to PR. Then only the 3 points will be collinear. So with the help of distance formula, we are finding the first distance between P and Q. That will be 2 minus 1 whole squared plus 3 minus 5 whole squared under root. When simplified, it will be root 5 and 2.24. You should know how to find the square root of numbers. Now the next one, QR. Minus 2 whole squared plus minus 11 minus 3 whole squared. Simplify this. Under root 212, that will be 14.56. Now PR. PR will be minus 2 minus 1 whole squared plus minus 11 minus 5 whole squared here. That will be minus 3 whole squared plus minus 16 whole squared. 9 plus 2, 56, 265 square root, 16.28. Now you can see PQ plus QR is equal to 16.80. So we can see PQ plus QR is not equal to PR. Therefore, the 3 points are not collinear. The question is, find the point on the x-axis which is equidistant from this and these 2 points. Let us keep the point on x-axis be px, 0 and the other points be a2, minus 5 and b minus 2, 9. I have shown it here. Now, equidistant means we have to find the distance between the point P and A and also P and B. So first we are finding PA. We write the distance formula x2 minus x1 whole square plus y2 minus y1 whole squared. So it comes like this, 2 minus x whole squared plus minus 5 minus 0 whole squared. Expand this and simplify. You will get x squared minus 4x plus 29. The next one will be, here I will show you, minus 2 minus x whole squared plus 9 minus 0 whole squared. Let me tell you one thing. If it comes like this, minus 2 minus x whole squared, then you can ignore the minus sign and write 2 plus x whole squared. Here you can see minus a minus b whole squared can be written as a plus b whole squared and expand. That's what we have done here. So when simplified, you are getting x squared plus 4x plus 85. Now PA equal to PB, therefore equate the two, this and this. When you square the both sides, squaring both the sides, the under root will go and the x squared and x squared will also go. Take x to the left hand side and the number to the right hand side. You will get minus 8x equal to 56, x equal to minus 7. So the point on x-axis is minus 7, 0. The question is, find a relation between x and y such that the point x, y is equidistant from the points 3, 6 and minus 3, 4. we'll keep the point on x-axis to be px comma y, and the other points q3 comma 6 and minus 3 comma 4. Now we will find PQ and PR and equate them. PQ equal to the distance formula x2 minus x1 whole square plus y2 minus y1 whole square. So it will be 3 minus x whole square plus 6 minus y whole squared. Expand this and simplify. You will get x squared plus y squared minus 6x minus 12y minus plus 45. Now the next one, minus 3 minus x whole squared plus 4 minus y whole squared. Just like the previous sum, instead of minus 3 minus x, we can write 3 plus x whole squared. And this will be as it is. Expand this and simplify, you will get x squared plus y squared plus 6x minus 8y plus 25. Equate PQ and PR. Now squaring both the sides, the under root will go, and also x squared and y squared also will go from these two sides. Now, so here what is left? Minus 6x minus 12y plus 45 equal to 6x minus 8y plus 25. Bring everything to the left hand side, equal to 0. Now simplified, you will get minus 12x minus 4y plus 20 equal to 0. Take minus 4 common and eliminate. You will get 3x plus y minus 5 equal to 0, which is the required relation. Now this is nothing but a linear equation in two variables. This question may be a bit difficult for the basic students, but the standard students should definitely do this. Now, there are many questions in the textbook and in the board exam questions also. The distance formula being used to prove different type of triangles and different type of quadrilaterals. Here, suppose you are given a triangle in which the three coordinates are given. If it is a triangle ABC, the coordinates of A, B and C are given. With the help of distance formula, we will find AB, BC and AC. Now let me tell you about these things. If all the three sides of the triangle are equal, then you will say it's a equilateral triangle. When you find all the three sides, if two sides are equal and the third is not equal, then the triangle will be isosceles. Another important fact, in a triangle, the median divides the opposite side equally. So you may have to find the midpoint of the opposite side to prove it is a median with the help of midpoint formula. And the last one, in a triangle, sum of any two sides is greater than the third side. This you have learnt in your earlier classes, maybe in your 7 or 8. Here, if you find the three sides using the three coordinates, add two sides and it should be greater than the third side. You have to find thrice, 3 times you have to do that. So this may come in your exam as a MCQ question. So be ready for that also. Now let me tell you about the quadrilateral. In a quadrilateral, if all the four sides are equal and the diagonals are also equal, then it is a square. You will be given the four vertices and tell you to check whether it is a square or not. Now, if all the four sides are equal but the diagonals are unequal, then it is a rhombus. Similarly, if the opposite sides are equal and the diagonals are equal, only the opposite sides, then it is a rectangle. If the opposite sides are equal but the diagonals are not equal, then it is a parallelogram. I haven't worked out any sum because you have got sums in your textbook and you have to find the distances. Maybe 6 times you have to do for proving a particular question. In this particular sum, you have to find the coordinates of the points of trisection of the line segment joining this and this. I have drawn a straight line here, line segment. There are two coordinates A and B at the two ends. The 2 points C and D trisect the line segment, means divide equally. This portion equal to this equal to this. Now you should know one thing. C divides AB in the ratio 1:2 and D divides AB in the ratio 2:1. This part you should know. If you understand this portion, with the help of section formula, you will be able to do the sum. Now the first one, write the section formula, and here it will be 1 into minus 2 plus 2 into 4 upon 1 plus 2. And the next one here, 1 into minus 3 plus 2 into minus 1 upon 1 plus 2. Simplify this, you will get 2 minus 5 by 3. Second thing I told you, D divides AB in the ratio 2:1. Now the same section formula here, 2 into minus 2 plus 1 into 4 upon 2 plus 1. And the next one will be 2 into minus 3 plus 1 into minus 1 upon 2 plus 1. Simplify this, you will get 0, minus 7 by 3. Now C 2, minus 5 by 3 and D 0, minus 7 by 3 are the two coordinates of the points of trisection of this line segment. The next one, let me read. If A and B are minus 2, minus 2 and 2, minus 4 respectively, find the coordinates of the point P such that AP equal to 3 by 7 AB and P lies on the line segment AB. In addition to the previous sum which we have just discussed, this is also another important sum, and the students find difficulty in understanding this part. You are given AP equal to 3 by 7 AB. I have written here. And I am bringing AB down. So I am getting AP upon AB equal to 3 by 7. But we don't want AP is to AB. We don't want AP is to AB. We want AP is to PB. So 7 minus 3 will be 4. Write 4 here. Now AP upon PB or AP is to PB will be equal to 3:4. Now the same section formula, with the help of these 2 points and the ratio 3:4, we will find the coordinates. So m1x2 plus m2x1 upon m1 plus m2 and m1y2 plus m2y1 upon m1 plus m2. So here what we will do, 3 into 2 plus 4 into minus 2 upon 3 plus 4. Then 3 into minus 4 plus 4 into minus 2 upon 3 plus 4. Simplify this, you will get minus 2 upon 7, minus 20 upon 7. So the coordinates of P are minus 2 upon 7, minus 20 upon 7. So this point divides AB in the ratio 3:4. Let me read this question first. Find the ratio in which the line segment joining this and this is divided by the x-axis. Also find the coordinates of the point of division. Till now we were finding the coordinates. Here you are given the coordinate, but you have to find the ratio. So we will go in a different way. Let the line segment joining this and this is divided by the ratio k:1. Why we are giving k:1? Because if there are two unknown values, it may be difficult to get the ratio. So we are having only one unknown value k here. So the ratio is k:1 and the point on x-axis is x, 0. write the section formula and substitute the values accordingly. It will be k into minus 4 plus 1 into 1 upon k plus 1, and the next one k into 5 plus 1 into minus 5 upon k plus 1. Now you simplify them. You will get the two coordinates like this. Now we will, here it is 0 and here it is x. So we will equate the second, the y coordinate only with 0. K plus 1 will go, when you cross multiply it will become 0. 5k minus 5 equal to 0, 5k equal to 5 and k equal to 1. 1 means 1 is to 1 or 1 by 1. Now we will substitute the value of k in the first one only so that you get the value of x, because the second value is 0 only. Substitute here and get the value of minus 3 by 2. So the coordinates of the point of division, that is this point, is minus 3 comma 2, minus 3 by 2 comma 0. Let me read this question also. If 1 comma 2, 4 comma y, x comma 6 and 3 comma 5 are the vertices of a parallelogram, taken in order, find the values of x and y. I have drawn a parallelogram here. These are the 4 vertices. There is an unknown value of x and here there is an unknown value of y. One basic aspect you should know in a parallelogram and also in a square and rectangle, the two diagonals bisect at the same point. So the midpoint of AC will be the same as midpoint of BD. Here we will be using the midpoint formula. I have written here, let the 4 vertices of the parallelogram be this, this, this and this. And in a parallelogram the diagonals bisect each other at the same point. Therefore midpoint of AC equal to midpoint of BD. So midpoint of AC will be 1 plus x upon 2 comma 2 plus 6 upon 2. Simplify, you will get 1 plus x upon 2 comma 4. Finding the midpoint of BD, it will be 4 plus 3 upon 2 comma y plus 5 upon 2. You will get this as the midpoint of BD. Now we should equate 1 plus x upon 2 with 7 upon 2 and 4 with y plus 5 upon 2. And when you simplify, cross multiply and all, here the 2 will get cancelled. So 1 plus x will be equal to 7, x equal to 7 minus 1 equal to 6, and y will be 8 minus 5, 3. So the values of x and y are 6 and 3 respectively. This sum, find the coordinates of a point A where AB is the diameter of a circle whose center is 2, minus 3 and the coordinates of B are 1, 4. You can see from here. You should know the center is the midpoint of AB. So we will use the midpoint formula. So the coordinates of B is 1, 4. Coordinates of P will be x1 plus x2 upon 2, y1 plus y2 upon 2, the midpoint formula. That will be x plus 1 upon 2, x plus 1 upon 2, y plus 4 upon 2. Now we are given the midpoint, so equate with 2 and minus 3. So x plus 1 equal to 4 and y plus 4 equal to minus 6. When you cross multiply, x will be 4 minus 1, 3 and y equal to minus 6 minus 4, that is minus 10. The coordinates of B are, the coordinates of A are 3, minus 10. This is a bit difficult sum for the basic students, and the standard students can definitely manage. Determine the ratio in which this line divides the line segment joining the points this and this. This is a linear equation in two variables. It represents a straight line in a coordinate plane. Let the point P divide the line segment this and this in the ratio k:1 again. We'll write this one, write the section formula, and using these three we will write here. K into 3 plus 1 into 2 upon k plus 1. Then k into 7 plus 1 into minus 2 upon k plus 1. When simplified, you will get this one. Now, I have already discussed during the video on linear equation in two variables. If you are getting a point which is on a straight line, it should satisfy the equation. I mean, when you substitute these two values at the place of x and y, ultimately you should get 0. So because of that, we are substituting these two values in the place of x and y here. You have to take the LCM x plus 1 and you will get the numerator like this, and here it will be minus 4 into k plus 1. Simplify this, you will get 9k minus 2 equal to 0. K plus 1 into 0 will be 0 only. 9k equal to 2, k equal to 2 by 9. Therefore, the required ratio is 2:9. So the present video is getting over here. I believe you must have liked my video. If so, please subscribe to my channel and share the videos to your friends. There are other videos on many other chapters which also you may like to definitely watch and be benefited for your final board examination.